topic is measures of central tendency. So that's a lot of words, and all it really means is we want to talk about the center of the data. And there are two types of centers, and you've already talked about this. This is not new, but I will be showing you some things on the calculator, we hope, to kind of take us to the AP level of doing this. So you've heard about the mean, and there's a new little symbol here, and I'm going to just circle it right here, and that is the X bar, and that is a symbol that we use for the mean or the average of the numbers. And you've been doing this forever. You just add up all your values, divide by the number of values you have, and that's your average or your mean. And so in this example, we could just put in our calculators these numbers and divide by the, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 26, 28, 30, 36. These are 32 scores. And so we could add them all up, divide by 32, the sum of the scores. And they're not scores, they are, yeah, they're scores from games. So we could sum them up using that sigma and divide by 32, and we could come up with this average. But I want to show you how to do it on the calculator because we need to get very proficient on the calculator. So I don't know how well this is going to work, so I need your patience with this because I got to learn how to zoom in and so you can see what I'm doing. All right, so anytime that I want to work with stat things, I'm going to hit the stat button right there below delete. So I'm going to hit stat, and I want to put in data or edit data. So I'm going to hit 1, and notice that there's already a list there. I would like to get rid of that list so I can type my list in. So I'm going to hit the up arrow key and highlight the list. I'm going to hit clear, and nothing will happen to your list. It doesn't look like anything's happened. Once you move down, use your down arrow, all of that data will disappear. So that's a quick way to get rid of a list without deleting each piece of it. All right, so I'm going to pause, and when I pause and come back, you're going to have your data in, and so am I. So pause the video now, put your data in, and when you hit enter again, then we'll have our data in. So I put my data in, and notice I always check that last line. See how it says L32? That means there's 32 data points. My last data point is the 32nd point. And remember, I counted and knew there were 32? That is a quick check to make sure you haven't missed any data. Now, you could have typed something in wrong, but at least you know you have enough data points. And so that's just a quick check of something you always want to do to ensure that you get this correct. Okay, so what I'm going to do now is I'm going to show you how to do something so that you can do it for your homework. So I'm going to sort this data ascendingly, and this really doesn't help us for what we're going to do. I just want to show you now so you can do it for your homework. So if you go to stat, and you know there's edit, there's sort A, sort D. That means sort ascendingly and sort descendingly. So ascendingly means you start with the small number and go to the large number. Descending is the backwards of that. Okay, so I'm going to second quit, and I got to do this on the home screen. So stat, sort A is 2, and you have to tell it the list that you want to sort. And I'm in list 1. I'm going to move my calculator so you can remind you of the button. Remember, L1 is that button above the 1, but it's blue. So it's second 1. Let me show you what my screen looks like. And then I hit enter. Now, you don't see anything, right? But if you go to stat, edit, now your list is in ascending order. And that might be helpful for some things we do later. And you're going to need to be able to do that for your homework. So I wanted to show you that there. Anywho, we have to find the mean, right? Because that's what it says, to find the mean. And we could do it by hand, but we're using our calculator. So I'm going to do second quit. All right? So I'm going to ask the calculator to do the 1 var stats like we did in the day 4 video. So I'm doing stat. So hit this. Can't see my finger. Sorry about that. Move that up. So I hit the stat button. So stat. And I want to calculate, so I'm just going to go over to calculate, and I want a 1 var stats, and we're looking for that X bar thing, right? So it's in L1, that's good, and that normally stays there, and I don't change it unless I need to. The frequency list I won't use a lot unless something goofy happens and I have some data that I need to do something else with. And go down to calculate. So there's your 1 var stat. So we're looking for that X bar, and there it is, 42.5. So I'm going to write down 42.5. Move my calculator out of the way. So that is the mean of this data. Okay? The other thing we could find out about this data is the median, and that is the point in the middle. And if you have 32 points, then I would need, ooh, that's even, isn't it? Okay, so if you have even number of points, there's not like a middle data point. So you have to take the 2 in the middle and find the average of them. So, you know, I sorted that ascendingly. Oh, that's going to end up being very helpful. So I'm going to stat, edit. All right, so let's look at that. If I wanted to find the median of this data, I need the middle number. But 32 divided by 2 is 16. That means there's 16 data points and to the left and right of the median, but the median's not a data point itself. So if I can go find data points 16 and 17, then it would have to be the average of those two. So let me go find those. And I know that I can find them because, remember that little number? There's 16 and 17, right? So 16 is 40 and 17 is 41. So the average of those two, or what's in the middle, is 40.5. So that's the median of this data. So I'm just going to write that down. The median of the data is 40.5. And I did that by finding the average of the two terms in the middle, because there's 1 through 16 and then 17 through the 32. And so the average of those two, add them up, divide it by 2, or y'all, what's in the middle of 40 and 41? 40.5. Sometimes it's not that easy and you actually do have to add them and divide by 2, but that was a pretty easy one, so we're not going to do work on that one. Okay, so we can find the two measures of central tendency are the mean that we found, that's the average, adding up all scores, dividing by the total number of scores, and the median, that's the number in the middle, if you put it in order. And that's why I put that in order, that sort A, and then I can find the median of it. All right, so the next little example on this page talks about, well, sometimes the mean's not always the best. And so they give you this scenario about having some scores, and you've got some really good scores, and then there's a 0 right there. This is not straight, it's driving me crazy. And so look at this histogram. This looks terrible, right? Here's all these great scores and big old gap, and then there's this crazy one out here. And so would finding the mean of these always be the best representation of the data? I mean, it would be the mean, gotcha, but would it be really a representative of how you've done? If you've made a 90, a 92, a 94, look at all these great scores, and then there's that 0. So maybe it doesn't make sense sometimes to use the mean, because that wouldn't be great. What if we looked at the median of this data? Let's look. There are 1, 2, 3, 4, 5, 6, 7. Oh, they're not in order, are they? Well, let me put them in order real fast. So there's 0, 86, 88. I'm sorting ascendingly by hand. There you go. And you know I have to mark them out because I get confused. 90, 92, 90, 92, 94, and 98. All right. So how many do we have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now I know you wonder why I do that every time. That means I've messed up sometime in the past and I've left off a data point, so I'm really weird about making sure I have it. So if we have 7 points, then we can go to the middle. There's your middle point. And I think that would be a much better representative of this person's progress than the mean that we would find for this, because the mean actually is calculated and it's 78.29, And that's not really I don't think that's representative of this person's work. I mean, why would they have this 0? Maybe they had a bad day. Maybe they just haven't taken the test, And so the 0 is just, I haven't taken a test yet. I haven't taken it. No, I can't spell, y'all. I just haven't taken it yet. I have not taken it. So if you look at my work and you take my mean right there, then that's not really representative of what I know. I just haven't taken the test yet. But the 90 would be a better representative of how I've performed in the class. So sometimes you use the mean and sometimes you use the median because of how it fits the situation. Okay. So I'm going to go to the bottom of page 20 and draw some pictures to kind of make some of the words on this page make sense. We have already talked about the median and how to find it. We talked about sometimes the mean's good, sometimes the median is good in some certain situations. So let's look at our 3 situations. We can either be somewhat symmetrical. Okay, that's symmetrical or somewhat. It won't be perfect. And then I'm going to put the right hand down. So if the right hand does not have data, that means I'm skewed right. I'm skewed right. It's where the data is not. On this picture, I'm putting my hand down and it makes an L. So I'm skewed left. I know that sounds funny, but that might help some of y'all. I do whatever helps me out, right? All right, so those are my situations. So if you're symmetrical, your mean and your median are about the same. So I think you can see that. So your mean is very close to your median. And that kind of makes sense of the median. The median would be in the middle right there. But why is the mean going to be kind of close to it? So if you think about it, if there's a point down here, there's also a point here that kind of evens it out. So when you do the average of all of it, it kind of ends up being in the middle. So remember when we talked about salaries of things? What if you had a symmetrical salary? Like if you had a 90,000 down here and you had a 10,000 down there because it was a 100,000 range, then they would kind of even each other out. And so if you had a 40 over here, you'd have a 60 over here, and they would average out to be a 50. So that's kind of what symmetrical means. You have the same amount away from the middle on both sides, okay? But what happens if you're skewed right? Well, I don't know exactly where the median is, but there's some values here and there's some values over here. I'm going to say the median would be somewhere about right there. That's where your median would be. That's like the middle of all the numbers. And the reason I didn't pick this high point is because there's some points over here because it's skewed right. There's some points over there, so I usually go a little bit past that. I don't know exactly because I don't know what the numbers are, but that's kind of an idea. But where would the mean be? Well, in this case, you don't have that balance. You have the points over here pulling that average towards it. Because if you're putting really big numbers in and you're adding numbers and you're adding a really big number, that's going to change your average. I mean, think about it. If you didn't have the points down here and you just had like people making $30,000, $40,000, $50,000 and you found an average of that, if you add $100,000 for the CEO, that's really going to change that mean. So your high values, when you're skewed right, those very few high values are going to pull your mean down. So your mean is somewhere to the right of the median. And then if you're skewed left, well, your median is probably about here. Remember, you've got, this is the test score thing. So you've got those low tests pulling that mean way down. So wherever you're skewed means you don't have a lot of data points, but they're really pulling your mean in their direction. So the way I remember this, so I know this is strange, wherever you're skewed, if you're skewed left, then the mean is to the, oh, I wrote left to the median. Then the mean is to the left of the median. Okay. Sorry, y'all. I'm talking and writing. That's dangerous sometimes. And so it says that up here. In a skewed distribution, the mean is further out on the long tail. I know. See, there's the long tail. And so the distribution is skewed right. The mean will be further to the right than the median. And that's why, because you have a few points, but when you add those in to that average, it really pulls the mean that way, towards those few points. Same thing with the low test scores. So if you have great scores and you've got these 80s and 90s, if you have, like, remember, oh my gosh, we just did one, didn't we? Heck fire, we did, right? Let's look at that. So here's your test scores, right? And we found your median was 90. But when you added that 0 in, that real extreme thing, then it pulled your mean that way of your median. And this is skewed left, right? Correct. That's skewed left, and so your mean will be to the left of your median. So remember, your crazy numbers that are out there by themselves are going to pull your mean in their direction. All right, hope this has helped a little bit. This is a huge, huge concept. So if you might want to talk with your teacher about this, but this is huge. And if you get this, there are a lot of AP questions about this. So I hope that's helped. That helped me a lot when I figured that out. So wherever you're skewed, your mean will be that side of the median, because I know there's not a lot of them, but they're very powerful in pulling your mean toward them. All right, hope that's helped. Thanks. Bye-bye.